All right, so welcome to SDE Skills Saturday night mock interview session. In this session, the participants are given the chance to experience and practice being an interviewer and an interviewee. Tonight, I will be interviewing Alex. All others are welcome to comment, ask questions, and share opinions in the chat. So have fun and hope we'll all learn something from this session. I'm going to be starting by giving you, Alex, the link to code interview. You can choose the language that you're most comfortable with. It's right in the chat. Let me know if you can open it. And you might also want to share your screen for the session. Let's see.
Okay, cool. All right, let me share my screen. Okay.
Awesome.
Cool. Can you see my screen?
Yes.
Okay.
All right. Before we jump into the coding question, I just wanted to ask you, like, if you can tell me tell me about a time when you experienced conflict at work, and tell me how did you overcome it.
So there was this cross-team project I was working on, and basically the project was encrypting data owned by our team, and it was like also consumed by the other teams as well. And we had to get together to agree on a timeline. So there was a lot of conflict because on one hand, it was like a security risk if the data was not encrypted. And on the other hand, their systems also need to be working. And it takes time for them to integrate with our system with the encryption. So we sat together for several meetings and we had to basically compromise on a timeline. So instead of like encrypting all data, we would provide like an API to get the data unencrypted. And when they're ready, we would disable the unencrypted data API.
Okay, and what was the result for that?
So instead of forcing them to adapt to our new encryption system, we split up the encryption system into like unencrypted, an API for unencrypted data and an API for encrypted data. And that way they had their timeline we provided a timeline that would work for them.
Got it. All right. Sounds good. Now, let's see. Okay, so this is what I'm gonna ask you. So you're given coins of different denominations and a total amount of money. So what I want from you is to write a function to compute the number of combinations that make up that amount. You may assume that you have infinite number of each kind of coin. So I'm gonna give you an input and an output. All right.
Okay.
Right here, I'm gonna put it in a comment. All right. So this is the input. I'm on 5, and then you have coins, and then the output is 4. All right. So the explanation, how did we come up with this? So you can do the following combinations. All right. So you can do either take the 5 only, or take 2 of 2s and 1 of value 1, or you can take 3 of value 1 and 1 of 2, and you can have 5 of value 1.
Oh, okay.
All right.
Okay. So what if like the amount cannot be reached? Let's say like the amount is like 0, then what happens?
If the amount is 0, meaning of if
Yeah,
the
so
input.
yeah, if like there's no way you can get like the coin amounts.
Yeah, then you output 0.
Okay, I see. And like, can the coin amounts be negative?
No, you always assume it's non-negative.
Okay, let me just write that down. Okay, don't know why it's red on the screen. Okay, so non-negative. And will the coin array always have like values? Or like if like the coin array is empty, do I return 0?
Yeah, you can assume that.
Okay. Inputs. So empty case would return 0. And no cases would return 0. Okay, so just, yeah, I'm trying to think about this. So can there be like duplicate coins? Do we like, if it's like 1, 2, 2, 5, like, let's say like the input was like 1, 2, 2, 5. Is that possible? Like,
So no, usually, so the coins provided in the array are usually unique. So it's a set of coins of values, but that doesn't mean that you can't take it multiple times. As you can see in the example, there is 1 to 5 coins, but you can, get to that value 5 if you add multiples of 2.
got it. So
Yeah.
the input array won't have duplicates, but then you can use the results multiple times.
Yes, correct.
Okay. So, yeah, I'm trying to think of what I would do for this. So I'm like thinking like a recursive approach. So for the example, let's say 5, so let's like, so this is like the current example here. And recursively, I would like try every single input. So subtract, so in the first case, I would like subtract 1. And so, and then keep doing it until the result is 0. And if the result is 0, I would add 1 back to the, add 1 to the output. And yeah, so similar, so I'm like thinking a recursive approach. Yeah.
Okay, so you can, I mean, if you want, you can, um, write it out what you think. How would you solve it?
Okay. Oh, so pseudo, like, okay, like, yeah, so, yeah, let's basically, yeah, okay. So, I'm gonna start with like private, so let's say the function, so input, so output would be an integer. So are the inputs and outputs both integers? Like it's like a list of integer, like an array of integer. Coins is like an array of
Yes.
integer, and amounts like an integer as well.
Yeah. Everything's integer.
Okay. Int is it get coin get coin combinations. Okay. Int amount int coins. Okay, so I'm gonna like work on the helper function first. So int amount left. So if amount left is equals 0, then return 1. So okay, so if amount left is less than 0, return 0. And then we would iterate through all the coins. So let's see, for int coin in coins. Okay, so I need like a temporary variable to hold this. So total equals 0. Total. Okay, I have to check if the coin value is actually don't have to, because then if the amount is less than 0, then return 0. Get coin combinations. Amount left minus coin. Okay. So I actually don't need a okay, let me think about this. So I'm just going to walk through a simple case to see if like my solution here works.
All right.
So let me just like put like a simpler case. It's like 3 and there's like 1 and 2. So the first recursive run, the amount left is still 3. So we would check like 2 trees, go into like 2 paths. So it would be 2, and we check 1, 2. Okay. Oh, interesting. So I think I missed something. So the order matters actually in this case, because like, so in the recursive case here, like I would still have like, so like for 3, like my solution would probably return like 3, but that's not the correct answer, because 1, 2 and 2, 1 happens, and there's still the same result. Is that correct?
Yeah. So the
I
order of
see.
that, yeah.
Okay, so the ordering actually matters. So, okay, I see. So let me try and fix my answer then. So, okay. So then I think I have to keep track of like the current index to make sure that like the same coin is in use multiple times. So int index. So, okay. Equals index I. Okay. 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 So then
What are
I
you
think
thinking? Mhm.
so I think I got to split like there's like basically two paths. Like so for like this example, 1, 2, also one. So I have to like somehow differentiate like something like 1, 1, 1 and like 1, 1, 1, 2. So the first case, like the index shouldn't change. So here, index should not change. And the second case, the index should update, add 1, basically. So like in the second revision, we would, if like, so let's say like this is like the first recursive call of this, then we should check for, it should go through all the cases here. Two, so let me just like make this a bit more clear. So this would be amount left, and then this is amount left, and then current combination, which we don't have to track, and index, so something like this. So in the first iteration, it'll be like 2, and we want to check this combination. And it'll be also 2, and we also want to check this combination. And we also want to check this combination. So 2, 2. And we don't want to, in this case, we don't want to check. So this is actually, let me just like make this the array. Okay, it's current coins left, something like that. Coins to choose from. So we have to check 1, 2, 3, and then this case would be like 2, 3, and this one would be just okay, and this one also would be 3, and be like, okay, what am I doing here? Okay, here, yeah, this is, there's 2, 2. Okay, so in the second recursive call, like for the 3, 1, 2 example I have here, we need to check the amount left is 2, and the coin values is 1, 2, and also 2 with the coin value, possible coin values of 2, and also the amount left value of 3, and the coin values left of 2. Does that make sense to you?
Yeah, it makes sense. Mhm.
Okay, so like let me try and like code this out. So okay, so if total, okay, I see. So if total is greater than, oh wait, what am I doing? Total amount left is greater than coins of I, total combinations. Okay, wait. Okay. Okay, okay. So this case is like the hunch. Okay, so actually there are 3 cases. Yeah. Oh, okay. Amount left minus. Okay, so this should be here. Actually, I don't think I need this check. Okay. And the last one would be coins index plus 1. And we also need to check the index here. It's like a safety check for the index. So if index is greater than equals coins. Okay, actually, let me put this as a second condition. Coins dot length. Okay, so okay, like now I'm thinking like, do I even need the for loop here? So I don't think I need this for loop here because we are going through every single coin. Oh, okay.
But you gotta go through each of the coins though, right? Because you have a
Okay. Yeah.
either. Yeah. Okay.
Yeah. Okay. Oh, okay. This wouldn't be. So yeah. Wait. Let me think about this for a second here. Oh yeah. So this wouldn't be index. It'd be I. Okay. So coins of. Okay. Okay.
Oh, got it. Okay.
Yeah.
So
Yeah. I
you're
don't.
passing the index, so yeah,
Yeah. Yeah.
you
Because
won't need
the
it for
index
yeah.
is already passed. I don't need the
Yep.
loop anymore.
Got
Actually.
it.
And yeah, it'll just be the index. Yeah. Okay, let me just fix up the code. Coins index, coins index plus 1. Left minus coins index. Okay, so the first case would be add coin at index and don't increment. The second case would be add coin at index and increment. And then the third case would be don't add coin at index and increment. Okay. And this function, the main function would actually call the helper function here. Get return amount, coins, and 0. Okay, let me just like go through this example again to make sure the code works before like I try and optimize it. Because I think the runtime here would be like exponential. Because every time there's like 3 branches every time.
Yeah. So what do you think the base of that exponent would be?
Like 3 to the n, I think, where n is like the size of coins.
Okay.
Yeah, so that's what. Yeah, because it splits in 3. Okay, yep. So first iteration would have amount left would be 2. So this is like the parameter. So let's call like GCC get coin combination 2, and then the coins would be the same 2. 2. So the first one would be the amount left. So amount left and index. So we check 2 and we always check index 0. And so this example is like the 3, 1, 2, 1. So I'm going through this example here. So, and it'll branch into 2 and then 1, 2 index 1. And the last one we just keep, so 3, and we increment the index, so it's 1. And this branches into 2, so it'll be like 1, and we just keep it at 0. And also 1, and we keep it 1. And this branches into 2. Actually, this, okay, so the amount left is 2. So it'll be like 0 and 1. 0 and 1. So keeping it there. And okay, I see. So there's a bug here in my code. So in the repetition, yeah. So in the case that we like both case, there's a double counting, because then when I increment the index, and for the cases I increment the index, I don't increment the index, the exit condition still happens. So have to somehow dedupe the case. So let me think about it.
Okay.
So this would be okay, 2. Okay, so in the case, this duped. Okay. Plus 1. Okay. I'm not sure if this would work, but like if I check the out of bounds condition first, it might.
So what exactly was the issue again?
So so in the case, like in the recursive case where we check the amount left of 2 and the index is 1. Okay. There's 2 of them, so the amount left would be 0 in both cases, as shown here. And basically the index would still increment, but then our cutoff condition would check that the amount left is 0 and return 1. But in this case, this would be a double count because we already reached 0. So so I think like by moving the exit condition of the coin length, it should skip those cases. But like, Yeah, let me think about it a bit more.
All right.
Okay, so let's just say the index. Yeah, so this actually doesn't work. So let's say there is another one, and our array length is like more than 2. So let's say we call something like some random, like let's say 1, 2, and 3, like 1, like something like, okay. So we do something like this, then it would still double count because the index, yeah, it will still double count in this case because it will still be like at 0. So I need some type of condition to check this. So I'm trying to think about that now. Okay, so something like that. Should not, this would not exit. So, okay. So, okay. Okay, so I think like adding a condition. So okay, so if only, so I think one way to dedupe the condition would be just checking if like the amount is like 0 or negative.
So in that
So
case, when it's negative, what do we return? We should return 0, correct?
right.
Yeah. Okay.
So
And
yeah. Okay. So if the amount left minus change is less than 0, okay, then let's, okay, wait. Yeah, I don't know if this works. Let me think about it. Okay, so index plus. Okay, okay, so if, okay, so if the amount is greater than 0, okay. Okay, doesn't. Okay, so okay, so I'm gonna try this and gonna think about if this works. Okay. Okay. So at least for this case, this would work. Although, so it would not check the, because the amount left minus coin is greater than 0, we won't check the second condition. And in the case that, so I don't think it affects any case that is negative already, because we don't want to check those case, it returns 0 anyway, so it doesn't add to the counts. So I think this works. I'm just gonna continue with my example here. This makes
okay.
sense to you.
Got it. Okay, so we can, as you said, we can start with the amount left, which is 5, right? And then we have the coins and then the index and how it goes down, the recursive steps. We can continue. Yeah.
Right. So so let me go back. So this case would work here. So So this case wouldn't be run. And this case, okay, let me just split this one. Okay. So in this case, this would only take the first branch, which is get combinations at the same index. So GCC 0 and 0, and this would +1 to the value. And then this one would be, so the value would be negative. So it would try, it would, okay, so it would try, one more, okay, okay, so it would be like -1 and 1. So this adds 0, and it would also try.
So you're starting with 2 of amount left, right?
Right.
Just a basic case. Okay.
Yes. So this case is, yeah, this is splitting from 3 and 0. So
Okay.
so it splits into these 3 statements here, because like the 5 case would take too long to compute, like manually. So
Yeah, that's true.
just stepping through this example, and then this would be we would check so I guess like one optimization I can think of would be just sorting the values, so we don't have to recursively keep checking. So because in this case we would check like index 2, but and we can just cut it off. So for example, like there's like but like I think I can do this later. So let's say there's like a input here that's like if, so let's say for the example input, let's say like so for something like amount equals 5, and the input is this, in the case, like similar case, let's say the amount left, so when we go recursively, when the amount left is less than like the current, if we have it sorted, if the amount left is less than the current value, we can do a cutoff, but in the current case is not sorted, so we have to still check every element. But I think this is like a minor optimization, so I'll
Yeah, so you need to first sort the coins, correct?
yes. So this would be like a minor optimization. I don't think it'll change the overall runtime. But
what
I'm
would
just
be like approximately the, the time complexity to do that?
oh, so the sort would be like n log n, but our over case is like still 3 to the n, so that doesn't make sense here.
It doesn't change.
It doesn't change the overall runtime in this case.
Yeah.
Okay. So yeah, that splits to 1, 2, 2, and yeah. So I think the recursive function, the method works right now, based on just like GCC 2.0. Like I think it'll take too much time to write out all the cases. So another way I can think of to optimize would be to memoize.
Okay.
So I see like we can just have like a hash map to with like the key as like the amount left and the value as the index.
Got it. Okay. Which index? Oh, we're talking about which coin? left, right?
the
All right.
index parameter, you
Mm-hmm.
mean.
Kind of
So
in the index is going to be kind of like the level of the tree,
oh
or
okay, yeah. The index is like the level of the tree, yeah.
so we start with 3 and then we go 3. We start with 0 and then we go 3 ways, and then
Yeah,
1 and then 3 ways. Okay.
yeah. So
All right. So tell me about the space complexity.
this displace complexity here, so every recursive call takes like O of one. Wait, you mean the memoized version or like the current
No, the
version?
one you have in, yeah,
The current version, okay.
the current version.
So every time, every call would be it'll be like basic so the max depth of the tree. Yeah, the max depth of the so every time the recursive function runs,
Mm-hmm.
it takes like O of one space. But then each recursive call also takes O of one space. But like for every call after the call, the stack clears.
Mm-hmm.
So the max would be like the max width of like a level. So I would
Yes.
assume like n. It would be like
Yeah,
n
O of
coins.
n.
Yeah, O of
Okay,
n.
and
Yeah.
yeah. If we consider the stack space, but the auxiliary one was actually O of 1 because you're not saving anything in a separate,
Yeah.
correct? Yeah.
Yes.
All right, cool. And how about the optimized one that you were talking about? What
So
is the time and the space complexity for that one?
it'll be so it'll be like O of the space complexity will be O of amount and so amount and coin length. So
Mm.
mn, assuming m is like the amount.
So
That
amount
would be
left.
the space
So
complexity.
that would be the space. Okay, so the amount left in the number of coins.
Yeah. And
Mm.
let me think about the runtime. So we would it'll be the same actually, because in the worst case we have to calculate all the combinations of the amount left and like every index. So
Mm-hmm.
the runtime is also the same. So we have to calculate every combination once.
Okay. Okay, cool. Um, all right. So I guess we can conclude this. I'm gonna give you feedback,
Okay.
and it's it's like very positive. I mean, I really like the way you handled the problem that I gave you. Um, so I like that you actually asked clarifying questions in the beginning, and covered some edge cases, and then you talked about how you're going to solve the problem. You didn't jump right away to writing the code, so you kind of like guided me through how to solve it. And then so I like the also that you verbalized your thought all the way, like since started solving the problem even before that. And I like that you got into the time complexity. I mean the runtime complexity, and also you cover the space as well. And it's good that you tested your code, and you find yourself found bugs, and you talked about optimization. So yeah, I don't see any negative things that I can point out about this, even though I mean you finished, and most of the things you finished. I mean, besides like maybe some minor bugs that might probably left, but I think you did an awesome job doing this. So about the behavior question, I can tell you just one thing, that when you're talking about your personal experience, use more I instead of we, and when you're explaining how you solve the problem, then be in more details of how you did it. So
Got it. Got it. Yeah.
Yeah, so that's what I have. If anyone has any, feedback, I see that P Satar, he asked for if you can run your code. I mean, we can do that if you choose.
Okay. Let me try it. Might be some bugs, but let's just see. So let's just use the example right here. Okay, so int coins equals and int amount left amount equals 5 and system combinations. What's it? Amount and coins. See if this works. Okay, there's some. Okay. Non-static. Okay, yeah, gotta make everything static. Oh, interesting. So some cases double counted.
Yeah, but it's a good thing that it compiles and most of the logic is kind of covered. So, and the way your thought process is, how you're gonna solve this is more important than actually having like a fully working code without bugs. Um, so yeah, I would say overall you did very good.
Thanks.
And so does anyone have any question, feedback, anything to tell to Alex? Ask Alex. You can jump in.
I think Alex did good. He was thoughtful about. I like the way his thought process went. He was methodical and explained throughout the process. And one thing at the end, right? We just have to. I put it in chat. Like if you can run the code so that just last kings also would be done, and then you can always mention at that point that this is my approach, and then there are other approaches like memorization and other things that also you can mention initially or only before you go with the code. Like right now I'm using this approach, but I could have done other approach also. Like I want to do one approach, and then once that works, I will do the other approach based on the runtime and complexity and requirement.
Got it. So yeah, you can also in the beginning actually ask like, are there any time or space complexities? I mean, constraints that I need to be careful for, because if they tell you, okay, I want in all one space, then you can sacrifice time. But if they don't care about space, then you can optimize time. So that's one thing. And yeah, the talking about different approaches is also good. But I believe that you did that in the beginning. So yeah.
Not much complaints. It's all good.
Yeah. Any other questions?
One more thing, I would also mention that if I was in Alex space, like I would say that I would also add a debug option just so that I can print the path that it's doing. So when it's actually going to the dynamic programming, when you're calling one function to other, so I will say that I will put a debug function where I will, if the debug function is run, I will print the paths which it took to generate the amount. as a interviewer, that will always show me that, okay, you just printed 6, but is that the right answer or not, right? If I give a different output, um, and if you can say that, okay, you know how to analyze and see the output, so that will always be a plus point.
Okay, I see. So I guess one question for me, like, would it make sense to like actually debug the code to go along for this case? Because like it's pretty complex to visualize. Like it took forever to write out the examples.
Yeah, I mean, you can try debugging. I mean, by testing it, you kind of like in sort of a way you're debugging it. So I would say when the way you do it, like when you go inside the recursive tree, of course you indent, and that's how you actually represent represent what value is being processed or returned. So um, I don't know if anybody has an idea how to kind of like make it easier by drawing differently um, as a visual they can share with us.
I'm not familiar with this tool to see if code interview allows to debug, but if there is a way, then you can just step through, take an easy, simple example like 2 digits and just run through the code and see how that, like similar to what you did from line 38 to 42, right? You can just run through a simple example and go through, like, explain your thought process, like what you did. Since I don't think so it has a debug and breakpoint options,
Yeah, I mean,
you just have to run through a simple example, 2 digits, and then have 1 and 2. I need to produce 3 or something, and just run through the code and then say that similar thing works with 1, 2, and 5.
so Alex, did you mean like you like a actual debugger um, within the environment, or you meant like debugging as manual debugging?
Oh, I meant manual debugging,
Manual,
actually.
yeah, okay, got it. All right, just wondering.
I think you already did little bit of manual debugging, right?
Yeah, he did,
I mean,
Yep.
yeah, so that is good enough for code interview.
Yes.
But if in some interviews you also can use your own Eclipse or IntelliJ or something, in those scenarios you can actually do a real debug and do breakpoints and see the solution.
Cool. Yep. All right. Do we have any other questions? I'm gonna, stop the recording. We can leave the questions after. Thank you all for attending. Hope you learned something. And
One thing is, you can stop it, but I just want to know if any other ways to solve this other than create